If you've ever played Minecraft single player, you've at one point likely felt,
Good morning, good afternoon, and good evening to all of you watching. Today we're going to explore integrals through practical Minecraft challenges. We'll be breaking down what integrals are, how they work, and solve real problems step by step. And before we proceed, make sure to smash like, hit that subscribe button, turn on notifications so you'll never miss another video. Now, let's begin. To break it down for you bare bones, integrals are essentially a way to calculate the total area or volume under a changing curve or surface. In Minecraft, we can visualize this through resource distribution and structural calculations. For you to further understand, let's say you discovered a massive mountain biome and want to calculate its total volume for a massive building project that you're planning on, maybe like a massive mansion sitting up top or a castle. First, we gotta divide the mountain into horizontal slices. Second, measure the area for each slice. And third, calculate the total volume by summing these areas. So let's say, for example, our mountain function is f of x is equals to negative x plus negative x squared rather plus 100. How can we find the integral of this function? Well, let's say we integrate it from x equals 0 to x equals 10. So x equals 0 to 10. Well, this is how it would look like. Integral from 0 to 10 with parentheses negative x squared plus 100. Of course, we shouldn't forget the dx. So this is our formula. Now what do we do with this formula? Well, we have to integrate it, of course. So we can separate this. So we can actually separate this. So from that equation, 10, 0, negative x squared plus 100 dx. We can separate these two into integral of 10, 0, negative x squared dx plus integral of 0 to 10 negative not negative but rather positive 100 dx. This is unnecessary, so we can just remove this plus sign. And with that, we can now calculate the integral. So basically, we basically just broke it down into two parts, which is the negative x squared and the 100. The negative x squared, which is of course the negative x squared term, and the 100 being the constant term. So the rule for integrating x squared is to increase the power by 1 and divide by the new power. So it is like this. So let's take negative x squared plus 1 over 2 plus 1, which is equals to negative x cubed over 3. So that's our first integral. And we add that with the integral of 100, which is basically equals to 100. Let's say there's an x here, which has a power of 0, which is equals to 1. And we add 1 all over 0 plus 1. That would equate to 100x over 1 or 100x. So with that, we can combine the two into negative x cubed over 3 plus 100x. So that will be our final answer. Just kidding. It's not actually the right answer because we forgot the plus c. Therefore, it's actually negative x cubed over 3 plus 100x plus c. We should not forget the c, which is it stands for a constant, which is just a placeholder for what we're gonna do later. So with that, well, it is not a fully final answer. However, it is just the final answer of the integration of negative x squared plus 100. So with that, we can now proceed with substituting the upper limit, which is the 10, and the lower limit 0. So basically, the two numbers that signify this, we can evaluate that 0 is the lower limit because it is in the lower part, and 10 is the upper limit being in the upper part. So with the equation, we can actually now calculate the upper limit and the lower limit. So it's actually something like this. So basically, f of a being the upper limit and f of b being the lower limit. So we actually subtract the two. So that would be negative 100. Oh, wait, no, not 100. It's negative 10 cubed over 3 plus 100 times 10 plus c. We can actually just remove the plus c for now, but you're gonna see why we can just remove it later on. So that would be negative 1000 over 3 plus 1000 plus c. Now we add 100 times 10, which gives us 1000. When we combine these, we get approximately 666,667. Step 3, checking the base at the starting point. Where the distance is 0, we do the same thing, cube 0, which is 0. Divide 0 by 3, which is still 0. Add 100 times 0, which again gives us 0. So the starting value is 0 and the total volume is just the difference between these two values. When we subtract 0 from 667, we're left with 666.67 cubic meters of space inside this mountain. Alright, here's the situation. We have a cave and its height changes as you move deeper inside. The height of the cave at any point is modeled by a simple rule. We take the distance from the entrance, square that per the steps, and multiply by negative one half. Then we add 20 to that value. What this means is that the cave starts with a height of 20 meters at the entrance and slowly gets shorter as you go deeper. After 10 meters, the height drops down to zero, meaning the cave ends. Our goal is to calculate how much space cave takes up by adding up all the tiny slices of the cave from the entrance to the end, which happens at 10 meters. To calculate the total amount of iron ore that can fit inside, we need to figure out the area of the curve that represents the cave's height. This process is called integration, which is just a fancy way of saying we're adding up all the little sections of the cave from the entrance to the end. To set this up, we'll add up the areas from the starting point, which is 0 meters, all the way to the end point, which is 10 meters deep. The rule that gives us the height of the cave looks like this. Multiply 1 half by the square of the distance from the entrance and make that value negative. Then add 20 to that. Now let's break this down step by step. Alright? Now it's time to solve this. Step 11, finding the general formula. To calculate the total volume, we first need to sum up the slices of the cave. First, let's look at the park, where we take the square of the distance from there, multiply it by negative one half. When we sum this up, we need to increase the power of the distance by 1, which gives us the distance raised to the power of 3. Then we divide by 3 and multiply by negative one half. The second part is much easier. We just add 20 times the distance from the entrance. So, after putting this together, our formula looks like this. Take 1 half, multiply it by the cube of the distance, and divide by 3, making sure it's negative. Then add 20 times the distance. Step 2G, plugging in the values. Now that we have the general formula, let's put in the values and see what happens at the endpoints. First, let's look at the endpoint, which is 10 meters. We take 10, raise it to the power of 3, which gives 1000. Now, we multiply 1000 by negative 1 half, which gives us negative 500. Then we divide that by 3, giving us about negative 66667. Next, we take 20 and multiply it by 10, giving us 200. When we combine these, we get about 33 cubic meters of space. Step 3, checking the starting point. We're not done yet. To be thorough, we'll also check what happens at the starting point, which is 0. If we raise 0 to the power of 3, we get 0. Multiplying 0 by negative 1 half still gives us 0. And dividing that by 3 leaves us with, you guessed it, 0. Adding 20 times 0 also gives us 0. Since nothing happens at the starting point, the total space inside the cave is just the value we calculated at 10 meters, which is about 30.33 cubic meters.